Okay, more problems from 9.2. This is number 25, and number 25 says write the first three non-zero terms and the general term of the Taylor series generated by e to the x at x equals 0. Okay, so all we have to do is we take our e to the x, which we actually were talking about in the previous problem. So actually you can still see it here. Hang on here, I'm looking for something. Okay, I guess I'll just use this, all right? Okay, so from here we had e to the x. You can still see it from the last problem. And then every time we just see an x, we put x over 2. So that's just going to be 1, x over 2 squared times the 1/2 factorial, x over 3 cubed times 1/3 factorial, etc. So you could write it like this, and then you could end up with a general term. So this would just be x over 2 to the n rather than x to the n times n factorial. And then you could raise this x to the n and this to the n. And this could give you a general term. So you could write it like this. Okay, so that's the first thing they want you to do. Write the first three non-zero terms. Okay, now write the first non-zero terms and the general term of a power series to represent g of x, which is e to the x minus 1 divided by x. Okay, so we take e to the x, and you just kind of work it out like a function. E to the x minus 1, well, that's what we were talking about in this problem up here. Actually, I can pull it down just a little bit so we can kind of see the work we did in 24. It's kind of nice to do 24 before you do 25. Okay, so if you look at 24, this ended up being e to the x minus 1. So if we take e to the x minus 1, which is this, that we used in number 24, all right, and then we divide every term by x. That's all we're doing. Let's see what you get. Well, if I divide that by x, I get 1. If I divide that by x, I get x to the first. If I divide that by x, I get x squared. So all we're doing is reducing the x power by 1 in each term. So we end up with this 1 over 1. So this is 1, and then x over 2 factorial, x squared over 3 factorial, and then this would be x to the n over n plus 1 factorial. You see, we've reduced the x exponent, or the exponent of x by 1, but the factorial stay the same because those aren't changed. And you can write it like this in this form, or you can write it in this summation from 1. If we change our index, okay, this would look a little different, all right? If I change my index to 1, then this would be x to the n minus 1, and this would be x to the n. All right? So we're going from 0 to 1, so we would just basically subtract 1. So this would be x to the n minus 1, this would be x to the n. Okay, so you can write it either way. Okay, so that's the A part, or the B part. This is the B part, okay? In the C part, they want you to, for the function g in part B, find g prime, and then use it to show that the summation from n equals 1 to infinity of n over n plus 1 factorial equals 1. So, a little bit more work on the C part. So I told you not to do these. I told you to try these little, don't try to do them all in one day. If you can help it. If it's a one-night assignment, it's going to be tough. Okay, if it's a weekend assignment, kind of spread it out. Otherwise, spend a little bit of time on them. It'll take a little bit of time to get these done. Okay, so number 25. For the function in part g, use it to show that g prime, well, this was g of x, so if I take g prime of x, and this was g of x written as this, so they want to show the g prime. Okay, so let's just take, this is g of x, e to the x minus 1 over x. So can I take the derivative of this? Yeah, I take the derivative of this straight out without doing it in a series. And that's just going to be using the quotient rule. Okay, low d high, less high, d low, denominator squared below. And I simplify this out, and there's the derivative. There's g prime of x. And then I can find g prime of 1, which equals 1. Just put 1 in here for x, so we get 1 times e to the first power minus e to the first power plus 1. over 1 squared just ends up being 1. Okay, so that's g prime of 1. Now that's just using the g function, but we can do it like that. Now we want to find the summation we want to use that to show that the summation of n over n plus 1 factorial equals 1. Well, this is g prime, so let's just find the derivative and show that that's going to be equal to the summation. So let's take the derivative of the series, because we'll probably get that in summation notation. Now, if I take the derivative of the series, I'll take the derivative of each term. And this was my nth term, remember, x to the n over n plus 1. Okay, remember from over here on the previous one, this was the g function, and there was the general term, x to the n over n plus 1 factorial. So that's the general term. So if I take the derivative, I'm going to take the derivative of that term, which would be n plus 1 times x to the n minus 1 all over n plus 1 factorial. Okay, so that's over here. So what I did was I wrote the function g of x, that was this, out. Then I took the derivative of each term. And that's going to be 0, and that's going to be 1 over 2 factorial, 2 over 2x over 3 factorial, 3x squared over 4 factorial. And then this was going to be, like I said, n times x to the n minus 1 all over the n plus 1 factorial. So this is g of x, and this is a summation n equals 1 to infinity. Okay? Because that would be the derivative, so I'm going to go from 1 to infinity. If I look at this and write it out, this will be, you can check this out. When n is 1, that's going to be 0, so I'm going to have 1 over 1 plus 1 is 2 factorial, 3 factorial, etc. So this will be my general term, so I can work this out using an index of n equals 1. A little different than the original index, but and the function because it's the derivative. All right? Well, g prime of 1 equals this, and g prime of, if I put 1 in here for x, I'm going to get g prime of 1 also. Well, or I should say, let's just say what g prime of 1 is, so let's put 1 in here. If I put 1 in here, that's going to be 1 to the n minus 1, which is just 1 to any power is 1. So I have this. Okay? But from way up here, what did I find that g prime of 1 was equal to? I found out way up here that g prime of 1 was equal to 1. So this way, by taking the derivative of this, I found that g prime was equal to 1. But then by taking the derivative of the series, I found out that the derivative of the series was equal to this, and evaluated at 1 is equal to, when x is 1, it equals n over n plus 1 factorial. All right? But since this is the same, g prime of 1, g prime of 1, they both equal 1, then they equal each other, and I've shown it. So take a look at that. That's a little tricky. It does make sense, and I think I wrote enough there for you to see. You just have to make sure that when you rewrite the derivative here, you check your index and make sure your index works for this form. Okay? I hope that helps.